Hi, Assalamualaikum everyone. Today we're going to present about triple integral in cylindrical coordinate using divergence theorems, or we call it as Gauss Theorem. But before that, let me introduce my team members. Let's get started. This is Noor Kamarina binti Ahmad Shukri. And the second one is Nurul Alia binti Muhammad Nasir. And this is Tunku Riana Izwani binti Tunku Saripul Bahari. And the last one is me, Nur Farisha binti Adnan.
In vector calculus, divergence theorem is also known as Gauss Theorem. It relates the flux of the vector field through the closed surface to the divergence of the field in the volume enclosed. Solid consists of some surface, so we can use surface integral to calculate each surface, but the solution will be too long. So, we use the divergence theorem for the flux integral to solve this method. F is a function of x, y, z, is a three-dimensional vector field. V is some three-dimensional volume, and S is the surface of volume. So, let's F, the function of x, y, z, equal to mi plus nj plus pk. The divergence theorem relates the divergence of F within the volume V to the outward flux of F through the surface S. So we get double integral S Fn ds equal to triple integral V div F dv. So instead of using double integral, which is double integral S Fn ds, we could use triple integral, which is triple integral V div F dv. Divergence theorem say that when you add up all the little bits of outward flow in a volume using a triple integral of divergence, it gives the total outward flow from the volume as measured by the flux through its surface.
So, for calculation, divergence theorem shows that double integral of surface vector f dot vector n ds is equal to triple integral divergence f dx dy dz. We know that vector f is equal to xy, yz, and zx. So, for example, we have a solid to calculate using the theorem. First of all, we need to find the divergence of f. Divergence of f is equal to delta f. As we know, delta is equal to d over dx, d over dy, and d over dz. So, to find delta f, we will use d over dx multiplied with xy plus d over dy multiplied with yz and d over dz multiplied with zx. That will be equal to y plus z plus x. So, to calculate, we need to know the integration boundary. So, from the sketching, we know the boundary for z-axis of the solid is 0 until 1 minus x. And for the y-axis, the boundary is from 0 until 2. And for x-axis, the boundary is from 0 until 1. So we will get the triple integral of x plus y plus z is from 0 until 1 minus x dz and 0 until 2 dy and then 0 until 1 dx. So we calculate the triple integral and then we will get the final answer is equal to 5 over 3. So that is how we need to calculate, or the step to calculate using the divergence theorem.
And this is our question that will be explained and solved by Rihanna.
Okay, Assalamualaikum. Today I would like to show how to solve the problem by using Gauss Theorem. So first of all, this example of our equation. The equation states that evaluate triple integral by boundary region of E, exponent negative x squared minus z squared dv, where E is the region between the two cylinders x squared plus z squared equal to 4 and x squared plus z squared equal to 9. With the limit of y is from 1 until 5 and z below than 0. The bounded region for our equation will be like this. The shape is like the ring. So our limit from y is y from 1 until 5. So because the exact strength and its the partial width means that we need use to the following modified version by cylindrical coordinate. So our x will be like r cos theta y equal to y and z equal to r sin theta. So we can easily describe the ring in terms of r and theta. So here is cylindrical coordinate for this problem. So the limit of the theta will be from pi until 2 pi. The limit of r is from the 2 until 3. So the limit from for the y is from 1 until 5. So after we got the limit from our bounded region, we need to plug in this limit to integral converting cylindrical coordinate even. So the integral here will be like this. Equal integral e exponent negative x squared minus z squared dv equal to bounded region from 2 pi, and then this from 3, so equal from 1 from 5, r exponent negative r squared dy dr d theta. So we need to evaluate the integral by y integration first. So y integration will be like bounded region of secant integral exponent negative x squared minus z squared dv equal to 2 pi, so we need from 3 to, so for the y integral, r e negative r squared y, so from 5 until 1, dr d theta. So when we solve the equation, we will get 2 pi, 3 2 and 4 re negative r squared dr d theta. This is for the y integration. So we need to do for r integration. So for r integration, we will do like this. Square figure dv equal to up to pi. So we got here is negative 2e negative r squared from limit from 3 until 2 until 3 and d theta. So when we solve the integration for r integration, we got 2 pi and 2e negative 4 minus e negative 9 d theta. So after we got our integration, we need to do for theta integration. Theta integration we will get triple integral e exponent negative x squared minus z squared dv sama dengan 2 exponent negative 4 minus exponent negative 9 theta, the limit from 2 pi until 2 pi. So when we put in the equation, we will get 2 pi exponent negative 4 minus exponent negative 9. So when we solve by when we calculate by equation, we will get 0.1143. So that's all how to solve the equation by Gauss Theorem.